Hey everybody, in this video we're going to go over universal gravitation and some of the practice problems that are found in the curriculum. So without further ado, let's get started. So the trick to this assignment is we need to understand our equations here. So the big equation we're going to use is that the force due to gravity is going to be equal to the gravitational constant g multiplied by the mass 1 times mass 2 divided by r squared. And so this is going to be our main equation we're going to use. And if you're thinking about, hey, Mr. Mueller, where did you get that equation from? Well, I got that equation right from the lesson and right from the formula sheet. In fact, if you go onto your Canvas and you look for the formula sheet here, you can find it right there. There's our formula sheet. So that's the one we're going to be using. Okay. A couple notes here. The g is a constant, and that value is always equal to 6.67 times 10 to the negative 11th newtons per meter cubed divided by kilograms squared. That's our units for that. So that kind of also tells you what the units of your item should be. That kind of tells us that our m's here should be in kilograms and r should be in regular meters there. Okay, so we do have to be aware of our units. Okay, so with this first one, we have two spherical objects. Their masses are 200 kilograms and 500 kilograms, and their centers are separated at 25 meters. They want to know what's the gravitational attraction between them. So what they're asking for is they want us to figure out, hey, what is the F value? They give us both forces, they give us the radius, and g is a constant. So all we have to do here is plug them into our calculator and go. So let's go ahead and see what that setup looks like. So our force here would be equal to our 6.67 times 10 to the negative 11th. I'll go ahead and put that in parentheses there. Multiply by my first mass of 200 kilograms, my second mass of 500 kilograms, all divided by 25 squared. And with this, at this point here, I would just encourage you to punch it into a calculator. And if we do punch that into a calculator, we get 1.0672 times 10 to the negative 8th. Now, when we're entering this in, we're going to want to make sure we follow sig figs. So here we have 1, we have 3 in our coefficient, we have 2 here. So we probably should round this down to 1.1 times 10 to the negative 8th. 10 to the negative 8th. And there I'm doing 1 sig fig plus 1 for uncertainty. And that would end up being our force here. That would end up being in newtons. And so there is our first answer for our problem. Our next problem is going to be number 4. And so in this one, we have two spherical objects with equal masses, and they experience a gravitational force of 25 newtons towards one another. Their centers are 36 centimeters apart. So notice here we're in centimeters here, not meters. And we want to determine their masses. So we want to know how heavy are they. All right, so again, we start off with our formula here. We're going to be using that. I'm going to put it all the way over here. F equals G m1 m2 divided by r squared. Okay, that's our equation. So notice here they're asking for what are their masses. We want to know what m1 and m2 are. Now they do tell us something helpful here. The masses are equal, so we can say that m1 equals m2. Okay, so if we were to kind of simplify this equation a little bit based on that, we can rewrite this as force is equal to g multiplied by m squared, because these are going to be the same. So m1 times itself is going to be m squared divided by r squared. Okay, so we know the force that was given to us, that's the 25 newtons. We know the radius, that's that 36 centimeters apart. We do need to convert that to meters, so be careful with that. And we know the gravitational constant. So we just need to do a little algebra here. And so if we do a little algebra, I'm going to multiply by my r squared, I'm going to divide by g. So I'm going to get r squared multiplied by f divided by g is equal to m squared. To get rid of the square, I square root both sides. And so the square root of r squared times f divided by g, whoopsies, I'm going to use my capital G there. So let me switch that around. Capital G for our gravitational constant. This guy right here would give me my mass. That would give me one of the masses. And since they're the same, we would know they're equal. So we go ahead and plug our values in. So our mass is going to be equal to the square root of 36 centimeters is going to be 0.03, oopsie, 36 centimeters, not 36 millimeters. I got a little confused in my head there. So it'll be 0.3636 squared multiplied by a force of 25 divided by 6.67 times 10 to the negative 11th. And so now we just have to punch it into our calculators. And we get 220,380 or 98.9. And so that needs to be rounded to sig figs here. So if we're looking, we have 2 sig figs here, we have 2 sig figs here, we probably should go to 2 here as well. So we're going to go to 220,000 kilograms would be our rounded answer if we were going to sig figs. Most of the time at this point in the course, they're telling you how many sig figs to go to each time, or excuse me, how many to round to. So there we can kind of see what should we do. All right, but we're just going to go with sig figs this time. So 200,000 kilograms. So very heavy, very close together. That's when we get a large gravitational force. All right, so let's look at number 5 here. So on number 5, again, we have 2 spherical objects with masses of 1.8 times 10 squared kilograms and 4.5 times 10 to the 8th kilograms. So two objects. This one is relatively bigger, but regardless, we have their masses. The gravitational attraction between them is 1.9 times 10 to the negative 3rd newtons. So the question is how far apart they are. Again, just like number 4, we're going to take our equation. I'm going to start all the way over here. G m1 m2 over r squared. And here, this time, we want to figure out, hey, what's r squared? We need to figure out what r is. We want to know how far apart they are. So in order to figure this out, again, we're going to do some algebra. And so this one's kind of nice. I'm going to multiply by r squared on both sides and then divide by f. So if I do a little algebra there, r squared is going to be equal to g m1 m2 over f. To get rid of the square, I square root both sides. So r is simply equal to the square root of g m1 m2 all over f. Again, this is a lot of just manipulating the equations. So we plug in our values. So r is going to be equal to square root of 6.67 times 10 to the negative 11th, multiplied by our first mass, which is 8.1 times 10 squared, multiplied by our third mass, 4.5 times 10 to the 8th, extend our little thing over the top, and then all of that is divided by 1.9 times 10 to the negative 3rd newtons. We punch that in our calculator, and we get 113.118 here if I'm rounding. So that would be in meters. And so I'm going to round that guy. We got 2 sig figs, 2 and 2, so we need to go to 2, so we should have a 1, 1. So we're going to have 110 meters here. 110 meters would be our final answer unless we're told to round differently there. Okay, 110 meters. And so there you have it. That's how you can get through a lot of these practice problems. Again, it's all about this equation right here and how you manipulate that to work with the problems. Hope this helps. Have a great night.